Hello, everyone, and welcome to the third seminar in our seminar series of I Can't Believe It's Not Better. And today it's my great honor to introduce our speaker, who needs no introduction, really, as I'm sure we're all big fans of her work. So on behalf of all the organizers, I would like to welcome Cynthia Rudin. Cynthia Rudin is a professor at Duke University. Her goal is to design predictive models that are understandable to humans. She applies machine learning in many areas such as healthcare, criminal justice, and energy reliability. Most notably, she's the recipient of the 2022 Squirrel AI Award for Artificial Intelligence for the Benefit of Humanity from the Triple AI community, which is also known as the Nobel Prize of AI. So we're very honored to have her here today. She's also a fellow of the American Statistical Association, the Institute of Mathematical Sciences, and Triple AI. She's also a three-time winner of the Inform's Innovative Applications in Analytics Award, and her work has been featured in news outlets such as New York Times, Washington Post, Wall Street Journal, as well as Boston Globe. And today, Cynthia will be talking about why applications really matter and why publishing them is really essential for AI and data science. So with that, I'd like to welcome you, Cynthia, and the floor is all yours.
Thanks, Sonali. I'm going to just share my screen here, and I would like to dedicate this lecture to the people in Ukraine who are suffering under being attacked. And so I just want to make sure that we always remember that we never forget what's happened there, and particularly Bucha and Borodyanka. Okay. All right, so I spent a few years of my life trying to predict power failures on New York City's electrical grid. It was a really hard project with extremely messy data, and this project really humbled me. And before I did this, I thought I knew machine learning, but I thought I had this. And then after doing it, I realized that my whole perspective was totally wrong. And I learned a lot. The Power Grid project wasn't your typical machine learning project at the time that I was doing it. The stakes were high. Most of machine learning came from like advertising or identifying dogs and cats or whatever on social media. Or they yeah, dogs and cats versus power grid reliability. And then also our data were really, really messy, and their data were from some repository, or well, like it was someone else's job to create the data, and your job as the machine learning person was just to create the algorithm, and it was someone else's job to use it. And also applications were viewed and are still viewed as not containing lessons that are important for a general machine learning audience, right? Asymptotics, somehow okay, but applications, no general lessons can be learned from them. And on top of it, there was this belief, like I want to say religion rather than belief, because that more mathematically elegant algorithms were going to drive performance. And I say it's a religion because there was really no proof that it was true. They were just kind of hoping that performance would be better because the math was more elegant. And because of that, interpretability had no value at all. Like there was literally zero value at all. It's only in the last couple of years that people sort of realized that like interpretability has value. And of course, for our problem, all the algorithms performed the same. And interpretability was actually driving performance because the data were just so messy and so difficult to work with. So interpretability was really the driver of performance. Now, so what were the lessons learned from this project? So first of all, we now know how to process power grid data to improve electrical grid reliability, right? This is a lesson that was learned. It's a generalizable lesson that others might want to take away, and they might want to adapt to other domains. We also learned that more powerful machine learning was no match for interpretability. So that's another general takeaway that you could use maybe for other domains. Like there exist domains where machine learning is no match for interpretability. And also more powerful machine learning didn't do anything. It basically just overfit. Like if we just applied a bigger algorithm to this noisy data, we were literally just going to overfit. We weren't going to get any better performance. So I knew that there was this like class of problems, important problems, where this obsessive eye that people had on tiny increments of accuracy made absolutely no sense, right? And this is what the whole machine learning world was focused on, was these like tiny little bits of accuracy at the complete expense of all interpretability. And I really wanted to share these lessons with the world, but it was really hard to do it because it was very hard to publish, right? So at the time, people just didn't care about interpretability, right? It's like I said, it's only the last couple of years that people realized it's an essential ingredient for trust. But before that, it was worse than worthless. And then to tell people that actually, if you try to use a more powerful machine learning algorithm, you'll overfit, nobody would believe that. Right? That wasn't something people would. That wasn't in the religion. And essentially, because it was so hard to publish applied papers, I learned that machine learning that matters doesn't actually matter to the machine learning world. Now, you see that this article was published in TPAMI, right? And we were lucky we got a good editor. But before this article was published, we sent it to IEEE Transactions on Power Engineering. And we didn't even change the format. It was exactly the same article. And they absolutely hated it. We didn't even get one positive review because what we were doing was data science. This is before the term data science existed, right? We were not doing power engineering. Power engineering had to have differential equations, whereas what we were doing was data driven. So the power engineers didn't want it. And then, it would have been terrible if we couldn't, if the publications were as they are now, we would never have been able to publish it in a place like TPAMI. It's really hard to publish in places like that. So there's like no really good place to publish it. And so the problem is that for all these applied papers, you have to go through all these hoops to get them published because they never fit anywhere, right? They don't fit. The power grid engineers didn't want to hear it. The data scientists didn't want to hear it. There's just nowhere that they fit. And there's almost no top journals or conferences in data science or machine learning that take applied papers. So that kind of gets me to the outline of this talk. So I'm going to talk about 4 points. Well, first of all, I want to make the point that applied science is still science. And then I'm going to talk about the benefits to science of publishing applied papers, benefits to the real world, broadening our community, and freeing our top scientists. All right, so let me go to the first point, which is that applied science is science. Okay, so science, this is the definition here. It's a knowledge or a system of knowledge covering general truths or the operation of general laws, especially as obtained and tested through the scientific method. Okay, science pertains to generalizable knowledge. It says nothing in here that such knowledge is limited to algorithms or asymptotics. If you discover a way to apply machine learning to a new field, then that's science. If you find a much simpler way to predict a specific kind of chemical reaction using an already developed machine learning technique, that is science. If you find a way to generate music or poetry using new ways to apply an already existing machine learning framework, that's science. And if you do a really good job of it, that is good science. Now, I'm not talking about a paper here that's a bake-off of methods for a specific data set. That's not science, right? I'm talking about actual generalizable knowledge and insight, okay? Knowledge and insight. So I believe applications should be driving machine learning methods development. Otherwise, it's just methods for the sake of more methods. But we can't actually really know what to work on if the applications can't be published. We are actually unable to leverage scientific lessons learned through applications if we cannot publish them. If you didn't know that there was a revolution going on in radiology right now, it's because you wouldn't know that from attending a machine learning conference, right? This is a major application of deep learning right now, is radiology. So I decided to do an interesting search. This is I searched through the list of accepted papers to NeurIPS 2021. And I was just wondering sort of like if I could learn anything from looking at their titles, right? So as we know, there's a bunch of areas where machine learning is really, making huge changes in the world. And I was just wondering if that would be respected in the NeurIPS papers, right? The paper titles. So I tried searching for bandits, which is a topic obviously I really enjoy. 63 papers on bandits, that totally makes sense. Hits for neural 276, so you'd imagine that totally makes sense. It's neural information processing system, so neural, right? We have a lot of papers on that use the word neural in the title. Here's some more adversarial, 81 papers, convex, 45, reinforcement, 135. Lots of people interested in reinforcement learning. That's great. Okay, what about, let's see, radiology, 0. Medical, 6. Clinical, 1. Mammo, so mammography, 0. Cancer, 0. Materials, 0. Material science is another area where machine learning is revolutionizing it. Chemical, 1. Reliability, 0. Poetry or poem, 0. Music, 0. Robot, 4. Climate, 0. And warming, like global warming, 0. I tried global. I got a bunch of hits for global, but those had nothing to do with global warming. They were like global optimization or global blah, blah, blah. So this to me is really scary. So what it indicates is that NeurIPS is not aligned with, it doesn't accept application papers, and it's not aligned with what's important in the world. Okay, now, Foster Provo had a comment about this back in 1996 about ICML. And he wrote, he wrote, let's see here, what we take from the program committee's decision, given the reviews, is that the important lessons from the real world are not as important as the ability to bundle up the complexity of a real world problem into a nice, neat conference paper. Applied work is interesting only if it looks like good academic work. And then Curie wrote this paper in 2012, where she said to a very large crowd of people at ICML that we weren't doing machine learning that mattered. And she told us what that would look like. And so she and I actually put together another special issue. So Foster put together a special issue in MLJ. We did too. And this was called Machine Learning for Science and Society, where we accepted a bunch of really great applied papers to show people how wonderful it would be to have applied papers published in the machine learning journal. Unfortunately, now machine learning doesn't want to accept applied papers anymore, but we were hoping it would turn into a regular track. Unfortunately, it did not. Okay, and things are even worse than ever. So I'm surprised that after 10 years from when we started this, I'm now giving this talk. Now, you could argue that it's just that people don't submit applied papers to NeurIPS. And that's why they don't accept applied papers, because people don't submit them. But that is not true. So what would happen if you did submit an applied paper to NeurIPS? Something where you develop a novel machine learning method for an important scientific application, and you want to show people how you did it. So I tried that. So I submitted one paper in NeurIPS 2020, and you can see why I haven't submitted since then. Anyway, okay, so I sent in one paper, and it was an applied paper on interpretable machine learning. The authors included 3 full professors. All of them were very senior women at Duke and Caltech, including a department chair. So these are very well-established scientists who've built their way up through the system. But these 3 people really know how to write papers. Okay. And the paper subsequently won a Best Paper Award from the American Statistical Association. All right, so below, I'm going to show you the single full review we got from NeurIPS. The paper was desk rejected, and I'm showing you the full review of what we got from them. Now, the first part of this review just looks like a form, just like these are reasons why we desk reject papers. So there's nothing personalized here. The additional comments here are where the review really is. So the first comment is that this paper reads more like a very interesting blog post than an academic paper. So in other words, they're saying that your paper, so our paper, is not even a real paper. Like, this is an applied paper. It's not even a real paper to this reviewer. And then they wrote, in particular, there's no discussion of related work. So the 46 papers we cited, I guess, just don't exist. And then they wrote, the use of the word interpretable seems like an attempt at buzzwording. So I've been working in interpretable machine learning since before the word interpretable became popular. In fact, I've been working in it for my entire sort of career. So they were basically saying to me that my field is not even a real field. It's just a buzzword. And then they wrote, they solved their problem with a very simple decision tree and then sell that as interpretable without actually making use of the interpretable quality of the resulting model. And then I was thinking, hold on a second, what are you talking about? And then I realized, hold on, there's absolutely nothing here about the domain of the paper. Like none of you know what this paper is actually about. You don't even know what applied domain this is because I haven't told you. But the reviewer didn't know anything about the domain and yet they attempted to review it anyway. Okay, and so their comment about making use of the interpretable quality, like how can you know that? You don't know anything about the field. And then they wrote, there was no exploration of alternative methods or baselines. And of course, we had a full experimental section with several baselines. Now, they wrote at the very end, the problem setting is indeed interesting and a more rigorous evaluation of machine learning methods in this space would be suitable for NeurIPS. And we already know that a rigorous evaluation of machine learning methods sounds like a bake-off, and that doesn't provide insight, and that's not what would be suitable for NeurIPS. So I complained to the program committee, and they said that this reviewer had over 10 years of reviewing experience, and so they decided that they would agree with the reviewer. And so what that means is that 10 years our community has had to put up with this person whose reviewing is not even suitable for viewing by graduate students who wrote this paper. This is insulting and not appropriate language. So anyway, look, we solved the problem with a simple decision tree. That decision tree had to be optimized very carefully, right? And the knowledge that this problem could be solved with a simple tree could be valuable to the people who are all using deep neural networks with novel architectures for solving this problem. It turns out you can do it with a very simple decision tree. Okay, so in other words, your dirty applied work doesn't belong in our lovely AI venues, right? We don't want this type of work getting a top tier publication. So where is it that you can publish applications? So here's where I've written enough applied papers and sent them to lots of journals that I can now sort of give you a kind of an overview of where I've sent things and where you can and can't publish things. So I'm going to give you a list of journals where I cannot publish applied papers. Okay, so these are places that have rejected my applied papers for being applied. Okay, so NeurIPS and AAAI. Also, IEEE transactions on big data. I would never send an applied paper there again. That was a disaster. JAIR. Well, these guys took forever to reject it too. Management science and nature machine intelligence. I had one applied paper in nature machine intelligence, and then everything else I've sent there subsequently has been rejected, so I no longer trust them. So here are the kinds of comments that we get. Things like, reviewer 3 said they have mixed feelings about the paper as the work is pretty domain specific. Yeah, that means that it's applied to a domain. So it is specific to a domain. And then here's another one. Based on the scope and extent of your results, we believe that your work is more suitable for publication in a more specialized venue in computer music, and I encourage you to submit it to such a venue. So yes, your dirty applied work does not belong in our top tier publications in AI. Okay. So here is where I can publish applied papers. So this is where I have been able to get applied papers in. And I want to point out that these are all journals. So they are all much slower than conferences, okay? So they take a much longer time to get papers through the system. And so that's pretty frustrating. But I mean, these are all, if you think about it, these are all pretty good. Like Journal of Quantitative Criminology is the top journal in quantitative criminology. Decision Support Systems is a good journal in information systems. Physiological Measurement, this is the top journal in natural language processing, and the Harvard Data Science Review, which is new. So, okay, let's think about it though. Where would you want your papers accepted? So let's say that you could fill your CV with this list or with this list. Which of these would be better for your CV, right? As a data scientist? Well, clearly this list would, right? This list, most data scientists don't even know about some of these journals. Okay, so let's think about then who, so also, oh, I should mention one more thing here. So a lot of applied venues would force you to switch the audience of your paper. So if you were going to write a paper on data science for, blah applied domain, you'd have to stick all of the data science into the appendix and just write the paper to the domain. So for example, if you were writing the paper for doctors or for like the medical community, you would have to take all of your interesting novel data science and plop it into the appendix, and just focus the paper on the medical stuff. But if you're, what is your audience? And my target audience is data science researchers who want to work on applications and think they can contribute to helping the world. So where is the publication venue that goes to that audience? Okay. So the issue is that many people would love to be able to share the lessons they learned from applications to other people who are like them, who are data scientists who want to learn lessons from these applications, right? You would never really know how machine learning is changing the world or could change the world through looking at NeurIPS or ICML titles. Okay, so I want to go through the next point. So benefits to the real world. So right now we publish overly complicated methods when simpler ones would suffice. And if we actually focus on problems that benefit humanity, we might actually solve them. All right, so it's been known for quite a while that for problems with tabular data, most machine learning methods have similar performance. And lately, I've seen a lot of like deep learning architectures for problems where I know we don't actually need neural networks at all. And I've written extensively about this topic, including this paper and this paper. So why do we use overly complicated models? It's because we think they're better, right? Simpler models can seem trivial. So I'm going to put back the statement from the review, right? They solved their problem with a very simple decision tree, right? This is a bad thing here to this reviewer, right? He thought it was trivial, but it was really good that we could solve this problem with a simple tree, and that's the point. So it just makes you wonder, like, how many important societal problems can we solve with a very simple decision tree? Maybe it's more than we think, but it would be really exciting if this were true, because people could actually use those models in practice. All right, so let's switch over to broadening our community. So I claim we should not limit our community to those who care primarily about methods development. That further limits our community to narrow training pipelines, and we really should not exclude those people whose primary goal is to directly improve the world. So I claim machine learning does not accommodate sufficiently diverse views of what constitutes top science. All right, so let's think about it. So we had a narrow set of trendy topics admitted to NIPS. I guess this is, back in the day, NIPS or NeurIPS, whichever one. And so what that meant was that there was no top machine learning conference to publish top quality data science papers. And so applied work had to be relegated to the second tier. Applied work is second tier work. Okay, so what would then happen is that the non-trendy subfields of machine learning were relegated to second tier, or to slow journals if you wanted to be in the top tier, right? To be really successful, you kind of had to value things the way the NIPS community did. You had to follow the trends, whether it was kernels back 20 years ago, or non-parametric Bayesian analysis 10 years ago, or novel architectures and theory of deep learning, right? Which is sort of now. And the thing is that for a vast number of data science problems, You don't actually need any of those things, right? I'm not saying you don't need new techniques, right? You don't always, you know, you just don't always need these kind of trendy techniques. But if you're in a high stakes setting, maybe you're better off like understanding and troubleshooting the data and the model and building in the domain expertise and trying to make your decisions relevant and trustworthy rather than designing something with a big complicated algorithm that you can't understand. Yeah, and so yeah. So if this is the set of papers sent to NeurIPS, only the small like trendy topics get in. And not only did this narrow set of NIPS worthy topics exclude important societal problems, but it also excluded topics that were important in handling data in reality, right? For many years, it was difficult to publish anything on interpretability in the conferences. And there was this kind of work that was important, but not trendy. And I'm going to call this like fringe work since it wasn't trendy. Okay, and part of the issue is that the only evaluation metric that consistently mattered to conference reviewers was accuracy on a test set drawn from the same distribution as the training set. And this is only really relevant for low stakes decisions. So what the field did was that it propelled researchers to create trendy algorithms at the expense of focusing on the data and the problems with actual benefits to society. So if you wanted to publish in NIPS or NeurIPS, it's better if you sort of live and breathe these trendy topics. And what that narrowness to the field did, it narrowed who could and would want to come through the academic pipelines, right? If you came from a training pipeline that valued these trends and taught you some serious linear algebra, you were probably in pretty good shape to publish at NIPS. But you know, how many people did that leave out, right? How many people's values did that leave out? And so I claim that excluding diverse, high quality work in machine learning means that you're excluding diverse voices in machine learning. Right? It leaves out people who think differently. It leaves out people who can never get into those pipelines because of what background they come from. And it leaves out people who don't want to follow the trends, right? It leaves out people whose value systems is different from the work that's being published in NeurIPS. And this effect of narrowing out the acceptable topics was amplified tenfold by the conference reviewing process. Like we all know that our field has low quality reviewing, right? But AI and machine learning are the only fields I know of where reviewers for the very top venues are non-experts, right? There's sometimes students who've never published a paper. And even if the students had published a paper, it might not be in the areas where they're reviewing. So here I had a reviewer on that NeurIPS paper that didn't know anything about the domain of the paper. And they often don't even know how to judge work outside of a trending area. And so no low quality reviewing made this thing an echo chamber. So yeah, this is seriously a problem. It's really hard to find good reviewers for papers that are on the fringe. And so more of those papers get rejected. And then you just have this kind of echo chamber. And there was no mechanism there's never really been a mechanism to contest it. And so that just kind of amplifies the problem. Okay, and like also the paper matching, we had this like automatic paper matching system. And we all know that papers that are sort of, don't fit into the trend, the papers that are statistical outliers, they probably don't automatically match to reviewers very well. And you couldn't even protest a bad review, right? There's really no reasonable mechanism to contest this. Okay, and so the people who really suffer from this bad reviewing, they're on the fringe. And so, even if the review team was completely wrong, right, the volume of papers is so large that they're not actually interested in doing a good job. So what they do is sloppy, the reviews are often insulting and unprofessional. And these kinds of words, frankly, are not appropriate for how we treat other humans, like, let alone provide a welcoming community for outsiders. And all of this trendiness might not be so bad if the trendy topics were better aligned with societal good, but they are not, right? And by excluding application papers, the researchers are out of touch from real world problems. And, as I said, this is like ongoing. And as I showed you, NeurIPS and other conferences are still sifting out applications papers. Now, for a long time, I just thought, okay, whatever, this is annoying. We can't publish applications, so what? But I realized that no, this is actually a serious problem that emanates from the academic world to the whole real world. Because if people in the field can't publish applications, then the top scientists in the world can't focus on applications. They've got to primarily develop algorithms and theory if they're going to publish in the top conferences. So then who is going to work on AI for good, right? It's not going to be the companies who want to make a profit. It's not going to be the academics because they can't. So who, right? We need the top people in the world focusing on important applications, not just people doing this in their spare time. And conversely, by excluding applied AI papers from the top conferences, we're actually excluding people from being academics whose sole goal is to, improve the world by applying AI. So here, for instance, you could say, oh, people can just, they can just publish in a different venue, an applied venue. But if you look at, for instance, the computer science rankings, right, the rankings of computer science departments, look at the conferences they accept. Right, there are no conferences in here that accept applied papers except for KDD, which has an applied track, and I will talk about that shortly. So in other words, the computer science departments, the rankings of computer science departments are based on only the theoretical and methodological papers. So they're incentivized to hire people who do no applied work, who do not waste their time doing applied work. All right. So I think any good data scientist from anywhere in the world should be able to publish in our field. Right, so, and then, yeah. All right, so I just want to finish up by providing what I think is the solution to the problem. I think it's obvious what the solution is. And the solution is that we should open an applied track in all conferences and journals in data science. We do have an applied track in KDD. However, that track is not good enough. It focuses on only deployment rather than on science. And currently, I've just joined the SIG KDD board, and I'm trying to help broaden KDD's scope, but I'm not there yet. And but I think we need like all conferences to accept applied papers. And I know they won't want to accept so many more papers, but if they eliminate these artificial barriers to having a smaller number of accepted papers, they can do it. And it'll make a huge impact on the field. And it'll make a huge impact on the whole world because it means then people will want to work on applications. And in the meantime, the other solution is you. If you are reviewing or editing an applied paper, you can make a difference in helping to propagate work on applied AI. You don't think you can make a difference doing these small things like reviewing or editing, but I think this question of who can do AI for applications hinges directly on decisions made by all of you. Thank you very much.
Thank you for the lovely talk. And I'm sure there's lots of questions. I know I have some. So if anyone has questions, just add them to the chat. So maybe I'll start with a basic, well, what I consider a sort of obvious question in my mind is, if you say that maybe you can open up these applied tracks for at these maybe these conference venues, what happens to the person that says, look, I don't work in healthcare. I work in maybe some other domain. My work is also applied, and then we're all sort of bucketed into this one applied track. And then we don't get specialized sort of feedback about, in terms of reviewing quality, we don't get the feedback necessarily from a person that knows much about that domain area. Would the solution then be to have multiple tracks for different areas, different applied areas, or how would that work in your mind?
Well, I'm just hoping for some change. How
Yeah.
exactly that change gets implemented, it doesn't bother me. But I think the reviewers should be matched more carefully.
Yes.
So, for
Okay.
example, if you're working in like AI for medical stuff, you should get reviewers who do AI for medical stuff. There's a lot of people working in that area.
Absolutely.
The problem is when you have like a new domain. So when you're doing like I was doing machine learning for manhole fire prediction. Like there's no reviewer who knows anything about that.
Mhm.
So you've got to find some reviewer who's open-minded and who's like, well, I come from this other domain, but I can still review this because they've explained it to me in a way that I understand why it's valuable.
That makes sense. So another question I have is like, what do you say to a PhD student, or how do you even incentivize a PhD student who's like looking to move ahead in their careers? But then when you see even what employers potentially ask for, they only seek candidates who have publications, let's say in top tier conferences. So how do you like leverage the two basically so that they can have good career prospects, but they can also do work that matters for society?
That's a good question. And that's why I'm suggesting that we open these applied tracks so that these students who actually care about applications can publish somewhere and it still is top tier. I think that is the solution to the problem rather than sort of telling the students to do things that might not be beneficial to their careers. My students who do applied work also do methodological work because that's the only way that they, I mean, you know, I can't have too many students who do just applied work. I mean, I have maybe like 1 or 2 students now who are like really applications oriented, but the rest of my students, they have to do methodology. And part of it is because they love it. I mean, we do love doing methodology, but you know, they have to do the methodology in addition to the application. And they have to focus their efforts, their publication efforts on methodology. So yeah. And also, I mean, just another question, like another answer related to what you asked is about like, how do you deal with like getting these reviews back where the reviewers just insult you and you have these, like, this is this student's first paper.
Yes, it's like, very demotivating, I can imagine.
Yeah, it's like,
I remember this happened to me as well. So
why are we doing this to our students? Like, you know, and then me as an advisor has to say, you know, don't worry about that review. That was just some stupid reviewer who didn't know anything. And the student's like, but you know, I worked for 1.5 years on this. Do I trust you? You know, it's like, oh my gosh, like, oh, it's so depressing for this whole generation.
So if we could have multiple tracks where students could potentially submit their work if it was applied, then how do we ensure that we match the right reviewers in the first place? Like, how do you incentivize people, say, from a healthcare community to review relevant work that, you know, is related to what they do from, say, a conference venue like NeurIPS or somewhere else?
So for healthcare, it should be pretty easy because there's so many data science researchers in healthcare that they can review each other's work, right? And to be honest, they would much rather review. Like if you require all of the people who submit papers to also review, there's going to be enough healthcare people to review each other's papers. That is not going to be a problem. And frankly, they're going to want to review each other's papers rather than reviewing the papers in other areas that they don't know anything about. So I don't think that's a problem at all. I think the challenge is the papers on the really on the fringe, like the papers, like I said, doing work on applications that nobody's ever worked in. And so for that, you need a set of open-minded reviewers.
So Stephanie, I think, has a question. Do you want to ask, Stephanie?
Yeah, sure. So my question was, like sometimes in NeurIPS and ICML, like they do publish application papers. So I don't know if you've looked at it, but like if you have, like, are there any trends in those papers? Like in my question, I said, my assumption is that these are usually like basically a method, but like they've then applied it to something and they kind of put that in the title, but maybe that's a bit cynical on my part. I don't know if there's any data to support that or if you have thoughts.
I think you're right. I think, yeah, the papers, it's very rare to find a purely applications paper. It's usually a method that, and that's fine. I mean, I think that's fine. If we're publishing methods with an application to whatever it is, that's great. We need more papers like that. It's very hard to get a paper through the system like that,
though. Okay, I think we have another question. Go ahead.
Yes. So first of all, thank you so much for the talk. It was amazing. Really enjoyed it. And actually, I was involved in the organization of ASTAT this year, and we made a plot about like statistics of how was the acceptance rate per domain, and applications was the lowest one. So to your point of, do people submit applications to conferences? The answer is yes, but they have the lowest acceptance rate. you were absolutely right on that point. I actually that also got me thinking about how to solve that, because I mean this was at least for me a very timely talk, because I noticed the problem, and then I was thinking like how to solve that. And yes, I thought about the thing that you mentioned about okay, so let's have they have tracks, no, like an applied track on each conference. But then I'm not sure if that would solve the reviewing problem, and that kind of touches like the question that you answered before. But I guess, like, for example, like applications are so diverse, no, that how do you ensure that there is expert reviewers for every one of them, for every domain, and especially, yeah, how do you ensure that, and how do you incentivize reviewers from, say, some particular application to be there reviewing for NeurIPS, ICML, and all the top machine learning conferences?
So, I mean, the fact that you even have to ask this question sort of gets to the point of like, well, we find it easier to find reviewers who are doing theoretical multi-arm bandit than we do to find reviewers who could handle an applied paper. And that's the problem, right? Because we have, since there's no, yeah, so that's exactly the issue. And there's no reason that people can't get reviewers. Like if there's a clear reviewer who's outside the area, you can just ask them to review, even if they're not like submitting to NeurIPS or whatever it is. So we just need a better review process, I think. And I think that would benefit everybody overall, even the theory and methodology people, to have just a higher quality review process.
So I think Melanie has a question as well about starting a journal track related to this. Go ahead, Melanie.
Yes, no, thanks a lot for the talk. I guess I think more and more people are resonating, right, with the ideas that you are advocating for. And I think at the moment, I think we're in a position where we can start thinking about how would an implementation of, that new journal that values applications would look like. But then, yeah, so one challenge here is often you get pushed in the two directions of, okay, if you care about the application, have you compared to tons and tons and tons of baselines that are valuable? Because obviously there is a lot of background work and understanding that needs to happen if you really want to solve a problem in an applied field. So I can see, like, yeah, so basically it is a systemic problem, and therefore it seems that we also need to be thinking like how to, like, what is the biggest challenge? And in my head, it's kind of how to, so if we were to design what are the criteria, of what papers will get accepted, I can imagine many papers that would be, as Stephanie was pointing out before, plug and play kind of method that also is trying to apply something, but not really, which is, by the way, all the applications of machine learning that actually don't care about applications, but need some applied work so that they get accepted, look like. It's like, oh, I'm applying here. It doesn't make any sense for the applications, but hey, here it is. I have some applied work in the paper. So I wonder how to tease out that kind of plug and play applied work that is not that interesting, honestly, from true, really high impact, high quality applied work that maybe has less of an impactful ML model, algorithm, but it's super valuable for the application. How to tease out these two? It's just, I don't know.
It's actually not that hard.
Isn't it?
You just go back to the definition of science, right? Does it have generalizable knowledge? Right? Is it providing you some insight into the domain that you don't have in any other way, right? If the paper's conclusion is, oh, I can increase my accuracy on this data set by 5% using a boosted decision tree, that is not a paper that we want to accept. If the paper says, something, I really now understand this particular bit of insight about this domain, like I really, I have some new scientific knowledge about how to build materials or how to understand chemical reactions because I use this interpretable machine learning method, that is science. Do you see what I mean? Like it's about knowledge. It's about knowledge, not just sort of numbers and performance.
That makes sense. Yeah. No, thanks.
So we have a question from Laurent in the audience. He says, thanks for the great talk. I wonder about maximizing the impact of applied papers. If an applied paper gets published in an ML venue, how does its knowledge or insights get diffused in a non-ML community?
Okay, so that's a great question. So first of all, the whole world is looking at the ML community for leadership right now, and we are not providing it. So the papers in the machine learning world do get disseminated very, very widely. People in medicine are reading them, even though they can't publish them. So first of all, the ML community, since it's so high profile, that's one way to do it. Also, there's no reason that you can't write 2 papers. You should write 1 paper geared to the audience that you want to target as a data scientist. So you want to do applied, so my audience, ideal audience is applied data scientists, right? Who want to like generalize from the types of things that I'm doing to their problems. But you can also send it to the medical domain or whatever domain, journal from that domain, and you can write an article that's designed for doctors that takes all the math and puts it in the appendix, and you can get your medical collaborator to sort of lead that effort. So there's no reason that you can't do both, but the problem is when you don't get the paper, but your collaborator gets to write that medical paper, but you don't get to aim at your audience, which is data scientists. Like, it's not just that I can predict heart attacks. It's that I designed this method that is specifically designed for this type of data set to predict heart attacks, and I want to share the insights of how I did that with you. That's what you can't publish. Yeah.
I think we also have someone who wants to ask a live question in the audience, so go ahead.
Can I ask?
Yes, go ahead.
Okay, thanks. Thanks, Cynthia. Very nice talk. Actually, working in the field of computational biology, I couldn't agree more that it is usually the simplest models that work best. But do you think it is like data science and machine learning, they are going in a way like mathematics to more and more abstract ways, right? So like, for example, in mathematics at Newton and Leibniz time, it was quite applied, right? So they were thinking how to build bridges across the cities. I don't know how the light is reflected from the mirror or these things, right? So are we also thinking, do we have kind of similar situation like then, for example, could they engineering fields emerge and separate from machine learning or so? But what are your thoughts? Do you see like this kind of similarity?
That's really interesting. Thank you for the lovely historical perspective. I am not sure. Yeah, I'm not actually sure. I don't know. maybe someone else can help me out with that one, because I don't actually know the answer to that. It's a great question.
Okay.
I have maybe a thought on that front. Cynthia, if you're interested. I guess it comes back to what you were saying before about like applications driving research. I don't know, I'm not a historian, I don't know how it was before, but it feels like we have a whole industry of people who do research for research's sake. And so you don't need to think about applications. And maybe that's a difference. Maybe previously there wasn't, I don't know, people who were academics for publishing papers and they were more motivated by solving problems. But that may be an entirely ahistorical take.
Well, there's always been this sort of love of math. And I think, part of it could be that, we didn't have data for a very long time. Right? It was a long time where we had no data. and so people got really into the mathematics of it because that they could do that, right? And it was very elegant, and it's still very elegant, right? The math is very elegant, but now we have data. So it's time we come around and figure out how to use it and allow people to publish with it.
I wonder if it makes sense to, instead of come up with new venues, to sort of link venues in a way. Like it would be great if there was an applied track at a machine learning conference that had a relationship with a biology journal, with a medical journal, right? And so when they get an applied paper that's applying to, say, DNA methylation, they can contact the editor of a good applied journal, recruit reviewers through there, and then you can have, maybe the ML reviewers can actually first read the review from the applied journal to be sure that this is good applied work, and then they can review the methods.
That would be nice. I mean, I will point out that that does require an extra step that the applied papers have to do that the methodological papers don't have to do. So it adds an extra obstacle, which is exactly the kind of thing I'm trying to remove. But I see exactly what you're getting at. Like, then you know it's good on the application side.
Right. You know, because as a machine learning reviewer, I do a lot of applied work, and I love this talk, and I mean this really resonates with me. But when I'm in the role of a reviewer for ICML, and I get one of the applied papers, I'm guilty of not trusting my own. You know, the paper says that they generated insight in this application that I don't have as much familiarity in, and I don't know how to evaluate that, even though even though I write papers that are exactly like that.
Yeah, and this happens. This is the general problem with just reviewing in machine learning. You got all these reviewers who know a lot of stuff, but they're not assigned to the right papers. And this is exactly the paper matching issue I was talking about. If we keep doing this, then we just have, well, the reviewers who do like, GANs, they can review each other's papers and they know exactly what they're talking about. But everybody else just like, whatever. No, the reviewers really don't care about that paper because they don't work in that area, So yeah, that's exactly the issue we have. And I really, if you're reviewing for an applied paper in another area, so what you might want to do is like tell the area editor, hey, here's another reviewer from outside NeurIPS that might be able to come and help review this. Like that's something you could do. And just please give the paper the benefit of the doubt. Like don't just go, well, I'm just not very excited about this because it's applied. That's the problem we have. It's like, well, this is applied and I don't really care about it. I don't really know this domain. That's the issue.
So do we have any more questions in the audience?
There's some in the chat.
Yeah, so Melanie's asking, what do you think about the identity of the machine learning community? Are we engineers? Are we scientists? Are we theoreticians?
And to that, I may add, for example, there is a type of work that is more trying to bridge the gap between communities. For example, when you have this very nice didactic paper that explains, so it goes back to the audience point that you were making, like who is the audience of a piece of work. So if I'm targeting clinicians, definitely I'm going to write a paper in a different way. And where does that work go right now? So if it's just pedagogic, so didactic, and there is no novelty, but still the novelty is how you are, translating and distilling knowledge such that other people can actually apply it in a way that suddenly it starts to make sense for them. I don't know, that maybe we should also value that, no? And then, yeah, sorry, related, any thoughts on this or identity?
So I view my identity as a data scientist, right? I'm fundamentally a data scientist, and I've been that way even before the word data science existed. And so, like I said, my audience is other data scientists. It's people who want to apply things to other domains. And so I'm perfectly happy listening to data scientists talk about applications to different areas of medicine, even if it's an area of medicine that I haven't worked in. Do you see what I mean? So that kind of, I think that sort of answers your question about who's the audience. Well, my audience is data scientists, right? I want to have math in the main part of my paper because I want the audience to be other people who can leverage that math for their domain.
Right, but I guess we also, sometimes the audience is people in the field, sometimes it's other data scientists, and sometimes even it's actually theoreticians, so that, hey, look at this problem that makes sense, so start to actually work on things that matter. Or, I mean, just being here a little bit cynical. So I guess a data scientist has many types of audiences, right?
Yeah, that's true. You're absolutely right. I mean, I've done theory before based on Rich Caruana's great experiments. So yeah, I mean, he wrote some beautiful experimental paper, and he said to me, why does Adaboost perform so well for ranking? And I was like, I don't know. And I wrote like 2 papers on it. So I designed all the theory and figured out why that happened. So yeah, you're right. Observations made by more experimental people, more applied people, can definitely be used to develop good theory. Yeah, so there's a huge audience for this stuff. And since the stuff can't be produced that easily or published that easily, it could be produced, but it can't be published that easily in the right places, then unfortunately it doesn't end up getting to its intended audience that often. And
I think this is a bit related to the, sorry, yeah, thanks.
Go ahead.
I think this is a bit related to the previous question, but I guess as a data scientist, do you have insights on how to choose ML methods to work on and develop further? You know, is it as simple as saying, oh, you know, in this field, there seems to be a big problem with conditional general models, and so I'll work on conditional general models? Or are there maybe further insights to?
So I think it's all domain dependent, right? So I work on interpretable machine learning. The reason I work on that is because I was working in the Power Grid project, and then I realized that these black boxes were not helping. Like the interpretability was what we needed. So that's why I started working on that. And then when I'm working in a different area, like material science or music or whatever, then I'm going to design models that are interpretable based on the definition of interpretability for that domain. So, you know, if you're like a Gaussian process expert, you're going to specialize your Gaussian process technique to that domain, right? And the insights you get from it. So that's how I determine what to work on is I talk to I have collaborators. They help me out. They explain things to me, and that helps me figure out what to work on.
Thanks.
Esther has a question. In addition to your great idea of getting all top-tier publication venues to open up tracks for applied machine learning, how difficult would it be for us to start a new journal called the Journal of, say, Applied Machine Learning or something like that?
So I think that would be extremely difficult. I mean, people have brought that up to me before, but the problem is that it's very difficult to establish a new top-tier venue, right? So it would take, it would be very risky to start something new, and it would take many years maybe for it to sort of, get to the top tier if it ever does. But the problem is if we continue to exclude things from the top tier, and then the top tier, the people doing methodology say, oh, that's applied stuff, that's not top tier, then it just stays second tier. The statisticians have been more successful at this than the machine learning people have. So the statisticians do have several applied journals that are considered top tier, right? So JRSSC and Annals of Applied Statistics, those typically would be considered top tier statistics journals. So those guys have somehow managed to figure out how to do it. But those are, like JRSSC, but there's also JRSSB. You see what I mean? So there are different tracks of that one same journal. And also like mathematical physics, there's mathematical physics and mathematical physics computation, right? So they've somehow, although I think mathematical physics computation is still sort of more methodological. But like Informs at least has like the Journal of Applied Analytics, which it's a great journal. It's like the top journal for like analytics in business, like operations research and management science, but it's not considered on the same tier as like management science and operations research. So
yeah, it's somehow this trade-off of like embedding it within the current system of like top tier conferences or something like that versus having it as a separate venue or separate location entirely. Related to that, I also wanted to hear your thoughts maybe about how important do you think it is in, say, like education and academia for like academics to basically embed applications into the work that they teach. So if we say teach students about a particular method, should they also be learning about applications of it and actually get to see some of that in practice?
Okay, so I want to go back to the last question first because I realized I forgot to say something really important and I'm so sorry about this. So there is a new journal at Informs. It's the Informs Journal on Data Science. And I was the chair of the committee that elected the editor-in-chief, who's Galit Shmuley, who is an amazing editor. So I know she's working really hard to get that journal to be a top-tier journal at Informs. So I really hope she's successful. And I'm doing my best to help her out in any way I can. I've submitted multiple papers to the journal, none of which have gotten accepted yet, but we're working on it. So if you want to contribute your papers there, you could be helping to make that journal one of the top tier journals in data science. Okay, now teaching. So, so actually, in about an hour, I will go and teach a class, and my class is all about applications. So I teach a class called Data Science Competition, where the students get to work in teams on some application, and it could be like a data science competition, or it could be just some application if I find a domain expert to come work with the students on it. So I really, I really strongly believe that that students should work on data science, like applied data science problems, and you can see that in my teaching directly. The only thing is that working on applied problems doesn't scale. So like my methodology class, I teach that to over 200 people every year. Whereas the applied class, I've got like 20 at most, because I have to limit the registration so that, because I have to work with these teams individually. Like I spend half an hour per team of 3 or 4 students, right? 2, 3, or 4 students. So it just doesn't scale up to the level of just the methodology work. Because these students are actually trying to do research, like they're just trying to discover stuff.
So maybe as a last question, Melanie has a question. Suppose a subset of the machine learning community decided to organize themselves and spend time to advocate for change on this front. Where do you think they should actually start?
Okay, so where I'm starting is KDD, because I'm on the SIG-KDD board, and there's a bunch of people who seem pretty open-minded about making a change. And so I'm gonna run a subcommittee with them. So I'm working on that. And if there is a group of people interested in advocating or organizing, I would love to sort of interact with them, because I think out of all the places, KDD would be the best place to start, because they already have an applied track. Like they already sort of, but the quality of their reviewing is extremely poor, right? So like that's something we need to improve in order to get anything, improved with KDD. So I think that's one thing. So AI Stats has higher quality reviewing.
Yes.
I think out of all the conferences, I think AI Stats is the one that has the highest quality of reviewing. So it would be great to talk to the organizers of AI Stats to figure out how this could happen. I'm not involved with that, but like I would certainly be open to talking with a group of people to try to have a conversation with them, but we'd have to create a solid proposal for how to do this. And so that's something that I'm working actively on now, is like a proposal for KDD. Like, what is it going to look like? And it would be nice to sort of hand that to other places and say, this is what I'm proposing here. What do you guys think of this? And see if people,
Absolutely
are into it.
Yeah, I'm sure you'd find a large following even from this audience, a large group of people who would basically agree with what you are pushing for. So yeah, absolutely support the initiative. Okay, so with that, I'd really like to say thank you for the super talk, and it was really nice to hear it. So thank you for everyone in the audience also for joining us today, and stay tuned for the next one. We're so happy to have you.